students, in this presentation, first of all I shall complete the remaining portion of the time study, and thereafter I shall take up the portion related to the development, implementation and maintenance of the new method in an organization. So, the time study, as I have said, is one of the work measurement techniques in which time for carrying out a particular job is identified using the stopwatch method, and suitable allowances are added to calculate the standard time and set the standard of performance. For successful measurement and accurate measurement of the time, it is necessary that the job which is to be timed is broken into the small elements, because the timing of a complete task as one element is generally not found satisfactorily, and it does not give the accurate time values for setting the standard of performance. Another reason for breaking the job into the elements is that it helps to time the things accurately, to find out the fatigue causing elements, to find out the productive and unproductive elements. So, it helps also to see the process into the greater detail. That is why, for the purpose of time study, task is broken into the short elements and each element is timed separately, so that accurate rating of the each element, accurate rating of the worker for each element can be done, and the time for each element can be obtained accurately, so as to set the time standard as accurate as possible. It also helps to find out the high fatigue causing elements, so that the steps can be taken to isolate those elements which are causing excessive fatigue, and also helps in fixing the suitable fatigue allowance to the workers who are carrying out those high fatigue causing elements. The reason of breaking the job into the elements is that it helps to develop the job specifications in detail, so that if later on workers start to follow the different methods, it becomes easy to detect whether they are following the standard practice or they are following anything else or deviating from the standard practice, because of which they may be taking longer time. Another purpose of breaking the job into the elements is to prepare the standard data bank, because in time study many elements are timed for the different small components, and the different types of the elements are timed which occur very frequently or very rarely, like walking, putting on or putting off, keeping the job aside, or switching on or switching off kind of activities are very frequently carried out in number of types of the operations. So, if the time values are developed for the common elements which are repeated in general in different kinds of the operations, then that helps to develop the data bank related to time values for carrying out those elements which are repeated number of times in different operations. So, development of the time values for small elements which are repeated in various operations helps to develop the standard data bank, and which can be used for time study in standard data method and also in predetermined motion time study method. And another objective of breaking the job into the elements is to separate the productive and unproductive elements. So, identification of the unproductive elements help to improve the method, and so as to reduce the ineffective time and set the standard time in such a way that it can be done in the less possible time, and more accurate time standard is set for the performance. For breaking the job into the elements, the certain guidelines are followed, so that the time can be measured accurately and it can be analyzed for setting the standard of performance. The element should be broken into the size as short as possible, so that it can be timed accurately. The element should be of as short duration as possible, which can be timed accurately using the available timing timing devices. The size of the element in turn depends upon the skill of the time study man, the method of the timing, and the recording technique which is being used. If very sensitive timing device is available, even very short timed elements can be obtained for the study. If the timing device is not very accurate and also the study man is also comparatively new, it is better to go for the element which are of slightly longer duration. And that is why the element should be broken as short as possible, so that it can be timed accurately by the time study man and the available resources in form of the timing and the recording techniques. Generally, with the stopwatch method, the elements of the duration less than 0.03 to 0.05 minutes are found difficult to accurate. So, the element should be broken in such a way for the stopwatch study method that they are of slightly of longer duration than this range of the duration. The element should not normally be longer than 0.4 minutes. So, as short as 0.03 minutes and as long as 0.4 minutes elements can be obtained for the analysis purpose, because we know the element is a very distinct part of the work which can be analyzed, observed and measured accurately. So, this breaking of the job into the elements depends upon that how efficiently it can be measured and what is the experience of the time study man in carrying out the time study of the small elements. When a job is broken down into the number of elements, then different types of the elements are segregated in one particular manner or other way, so that they can be treated according to their nature. For example, manually performed elements are separated from the machine elements. Manually carried out elements which are performed manually are rated by the time study man for when they are performed, while when the machine elements are carried out by the worker, means the machine elements are not rated, but the time for machine elements can be determined by the calculation and the machine elements are not rated against the normal performance. Another way by which the elements can be segregated is the time required in carrying out a particular kind of element. Like certain elements always take a fixed time irrespective of the nature of the job which is being done, the weight, length or any other characteristics of the work. So, the such elements which always take a fixed time in carrying out those activities and they are independent of the size, weight, length, shape of the workpiece. The time is found fixed and such kind of elements are defined as a constant elements. So, the constant elements should be separated from the variable elements. Variable elements are those for which time required varies with one or other characteristic of the product. For example, here the size of the size, weight, length, shape of the workpiece can directly affect the time required for carrying out the job. For example, the time required to tighten or loosen the screw depends on its length, while in case of the constant elements, switching on, switching off, putting the things aside are always constant. So, those elements which take fixed time, they are segregated as a constant elements, and the elements for which time varies with the characteristic of the workpiece, then those variable elements are segregated separately, so that they can be treated in different way during the analysis. For breaking the job into the elements, the job should be broken into the elements in such a way that each element has a definite beginning and end points, which helps in easy identification of presence of particular element. Regular elements should be separated from the regular elements. Irregular elements are those which occurs rarely and randomly. They may not be the part of the work cycle itself, while the regular elements are repeated consistently in regular or at a particular interval. So, the irregular elements are those which are not repeated in every cycle, like zig is cleaned off after every 10 parts produced, while the cleaning activity is an irregular element and its time should be spread over the 10 cycle. So, it will be detected only if the study is continued for 10 until the 10 pieces are produced, then one cleaning element will appear. That is why the study should be continued for a certain period of time, so that all those elements which are involved in production process can be obtained and they can be timed suitably. Other guidelines which are used in breaking of the job into the elements is that unnecessary motions are to be separated from those which are required for carrying out a particular job. So, so that unnecessary movements which are not required or which are redundant can be separated and isolated, so as to reduce the time required for carrying out the job and for improving the method which is being used for carrying out the job. Foreign elements and accidental elements also should be listed separately. And when these different when the job to be studied is broken down into the different small distinguished parts called elements, depending upon their nature of occurrence and whether they are required or not, how much time they take, are they of the fixed type or the variable type. The different elements can be grouped in the 8 different categories, like repetitive elements which occur in every work cycle. For example, putting the finished job aside and locating a workpiece in a holding device. These are the activities which will be repeated in every work cycle. So, the activities or the elements which are repeated in every work cycle are called repetitive elements, while the occasional elements are those which are not repeated in every work cycle, but they may occur in regular or irregular intervals. For example, adjusting the tension or receiving the instructions for foremen. So, those activities which are repeated in every work cycle called repetitive elements, while those activities which occur regularly or irregularly at certain intervals are called occasional elements. The elements can also be classified and categorized as constant elements, for which the time required does not change with the characteristic of the work which is being processed, like switching on or switching off, or using the measurement techniques or the carrying out the measurement using go and no go gauge. And the variable elements, an element for which basic time varies with some characteristics of the product, machine, process are called the variable element. And for example, cutting time for a job depends upon the section size, mechanical properties of the material. In the same way, the time required for cleaning the floor depends upon the area which is to be covered. So, in this way the time required for carrying out a particular element if depends upon the certain characteristics of the process or the product which is to be carried out, then those elements are termed as variable elements. Manual elements are those which are carried out by the operator by giving its own energy, while the machine elements are those which are automatically performed by the powered machine, like thread cutting, turning or the metal cutting operations. Another way of classifying the element is that the governing elements. So, governing elements and the foreign elements. The governing elements are those which takes the time longer than any other activity related a particular operation. So, the governing elements take the longest time than the other elements which are there. So, the governing elements take longer time than that of any other element which is being performed concurrently. For example, the boiling the water in kettle while setting the teapots and the cups. So, if the one particular element takes maximum time, and in that period all other elements can also be done, then the main element which is consuming most of the time is termed as the governing element. The foreign elements are those which are not considered as a part of the work cycle, and if it is found that the particular element is not necessarily part of the job after the analysis, then it is considered as a foreign element. And for example, like sanding the edge of the board before planing, or just like cleaning of the grease before carrying out the machining. So, those activities which are not required or redundant can be considered as a foreign element, or these elements may not be the part of the standard practice sheet. So, after breaking the job into the elements, next job is to the timing the different elements. So, the elements which are to be timed are listed down, and the time for each element is obtained by the stopwatch study, and each element is rated for the operator performance. So, that the average operator's performance and the average time for carrying out the entire job and that for each element can be obtained. So, the observation sheets are designed in such a way that the time for each element can be obtained easily and accurately, and the same can be recorded without any difficulty and confusion. So, that the data is available at the end of the recording for the analysis. So, the recording should be done in the observation sheet in such a way that it is available for easy analysis and easily understandable form. For carrying out the time study for the each element, it is not just sufficient to carry out the stopwatch time study once for an element. It is necessary to continue or to carry out the stopwatch study for each element until for the number of cycles until the representative time value for each element is obtained. So, that we will have some degree of confidence in our data related to the time value for each element, and we will also be sure of the degree of accuracy related with the measurement. So, the main principle that is governing the number of cycles for which an element is to be timed depends upon the accuracy desired and the nature of the element. Greater is the accuracy desired, larger should be the number of cycles to be observed. The study should be continued through the sufficient number of cycles, so that the occasional elements such as setting up of the machine, cleaning up of machine, sharpening of tool are observed for the good number of times. Then only the representative picture of all the elements involved will be obtained, and the observer and the time study man will have some degree of confidence on the data which has been recorded and on its accuracy. When more than one operator is doing the job, doing the same job, then the study should be conducted for sufficient number of cycles, but if more than one operator is doing the same job, it is preferred to carry out the study for a certain number of the cycles instead of carrying out the large number of cycles study for one worker. And so, if the same job is being carried out by the number of workers, it is always good to carry out the time study on the number of workers instead of selecting just one worker for the study. And when the number of workers are carrying out the same job, few cycles, say 10 to 15 number of cycles can be timed for each of the operator for each element, so that a representative picture representative time values for each element can be obtained instead of going for a very long study on the single operator. So, this is a very general kind of situation where preference should be given for timing the different elements for a group of workers rather than on a single worker. The three methods are commonly used to determine the number of observations to be carried out for each element related with the job, so that the desired accuracy and the degree of confidence in the data can be obtained. And these methods related to the number of cycles for which each element is to be timed are the use of the table, Mundell method and the statistical method. One by one these three methods will be covered in detail. Use of the table method is very common in the industries because of the economical reasons. It is a costly affair to find out the number of observations to be carried out for timing each element. Therefore, industries have developed their own tables for identifying the number of observations to be carried out for each element, and these tables have been developed in view of the time required for a particular element and its possible frequency in the organization or frequency of performing a particular kind of element. So, on the consideration of the cost of obtaining the data and the desired accuracy in the results, most of the companies have developed their own tables for use by the time study people. These tables indicate the number of cycles to be timed as a function of the cycle time and the frequency of occurrence of the job in the organization. In general, if the time value is more than cycle time is more, then less number of observations are carried out. It can be seen from this table that the activities with the different cycle times, say from 0.1 minute to the 0.7 minute, from 1 minute to the 12 minutes, from 12 minutes to the 1 hour, 1 hour to the 8 hours of the cycle time of a job or of an element. Here you can see this is the cycle time parameter, and this is about this row indicates the number of cycles per year of a particular element which can occur during the year. So, for an element of a duration say 0.1 minute, and if its frequency of occurrence is in range of 1 to 100, then 50 number of observations are to be carried out. If the frequency of occurrence is 100 to 10,000, then the number of cycles to be timed say 60, and the number of occurrence is more than 10,000, then the number of cycles to be observed for each element is 120. So, if from here we can see with the for a given cycle time with the increase in frequency, number of observations to be carried out for each element increases. In the same way, for a given frequency of occurrence, increase in cycle time decreases the number of observations to be carried out. For example, if the cycle time is 8 hours and a frequency of occurrence is in range of 1 to 100, then only one observation is required, while for the frequency of occurrence is 100 to 10,000, again 1, and if it is more than 10,000 then it is 2. So, increase in cycle time decreases the number of cycles to be timed for each element, and increase in frequency increases the number of observations for which each element is to be timed. The second method of finding the number of observations required for timing each element, it depends upon what is the degree of a scatter in the data which is being obtained. In this method, initially good watch readings are obtained of the work cycle, and then the maximum and minimum values are determined. Generally 10 readings are taken if the cycle time of the job is less than 2 minutes, and for the jobs more than 2 minutes, for normally 5 readings are taken. After taking these watch readings for 10 in numbers or 5 in numbers, their highest values and their lowest values are determined. So, using the highest and lowest values, the ratio of H minus L divided by H plus L is determined, where H and L are the highest and the lowest values of the reading which have been taken earlier. These readings may be of 10 in numbers for the jobs of for the job cycle time less than 2 minutes, and this ratio can be obtained from the 5 readings if the job cycle is more than of 2 minutes. So, from this ratio is further used to find out the number of observations from the table Mundell has proposed. This table shows the different values of the ratios like H minus L divided by H plus L with the different values in these rows. Here another set of the values for this ratio, and thereafter there are 2 more rows. Here this one shows the H minus L divided by H plus L ratio value of say 0.06. The number of observations to be taken is 4 if the sample size is of 5 readings. If we have taken the sample size of 10 readings, then number of observations to be carried out only 2. In the same way, for the different values of this ratio and for the different sample size, the number of observations required can be seen directly from the table. Another example, if we take, if the ratio value is say 0.4, then for the sample size of 5 readings, the number of observations to be carried out will be 190, while if the sample size is of 10 readings, then the number of observations to be carried out will be of 108. So, this is how using the preliminary survey of the cycle time of the job by the watch readings, we determine the highest and lowest value of the readings, and from the ratio of the difference in highest and lowest value and the sum of highest and lowest values ratio, the number of observations required for timing each element and the total work cycle is determined. The number of observations which will be carried out, number of observations for timing of a particular element or of the work cycle will give an accuracy of 5% and the 95% confidence level. If a precision of 10% is required with the 95% confidence level, then whatever number of observations are carried out or obtained for either 10 reading set or 5 reading set, and for a given h minus L divided by h plus L ratio, the same observation number value is to be divided by the 4. So, with the increase in precision of 10 plus minus, the number of observations required decreases. So, here if you will see the another method which is used for determining the number of observations to be carried out for each element or for the work cycle. So, on the basis that method is the statistical method, and this is the third method, and on the basis of requirement of a particular situation and the accuracy desired and the confidence levels which are required in the observed time values are decided. An accuracy of 5% and the confidence level of 95% is generally considered most reasonable in most of the cases. And for carrying out for determining the number of observations to be carried out for timing in each element, timing of each element, preliminary studies conducted in this method, say for n number of cycles, and then standard deviation of the time values is calculated. And after determining the standard deviation value of the sigma from the timed values, where small t represents the each watch reading, capital T represents the average of the n watch readings, and n is the number of watch readings in preliminary study which has been conducted. The sigma standard deviation in the data is calculated. Now, in order to find out the number of cycles to be timed, m is calculated in the statistical method by the following way. Here the standard error of the mean, that is epsilon, is used in the following equation. The number of observations to be taken for timing each element by the statistical method can be calculated using this equation, where x into epsilon equal to the a into t, where a represents the accuracy desired, t is the average value of the n watch readings which have been taken, and x is a factor. X is a factor which corresponds to the degree of the confidence desired. Its value is taken as 1 for 68% of confidence desired, 2 for 95% of the confidence level desired, and 3 for 99% of the confidence level desired. So, depending upon the degree of confidence desired in data, the value of x is put in this equation suitably. The standard error of the mean value of the time values which have been determined is also determined. It can be 2%, 5% or 10% as per the acceptable level of the error, and A is the accuracy and T is the average time value. So, for determining the number of samples to be timed, number of observations to be carried out in terms of the m, say, can be obtained from the following equation, where standard error which has been fixed, like whether it will be 2%, 5% or 10%. This standard error epsilon is equal to the standard deviation divided by square root of the m. M represents the number of observations to be taken for each element. So, value of m can be determined from the acceptable level of the standard error and the standard deviation in the data which has been calculated. Now, this is the another important point related with the time study, that the performance of the operator is rated during the study, and that performance is used for calculation for calculating the normal time. The observed time values are multiplied by the rating factor to find out the normal time. So, what is the normal performance and why it is required to find out the performance rating of the worker, that we will see in detail gradually. The normal performance is a concept according to which the what should be the speed of the work by which operator should do a given job or a given element according to the concept of the standard of the time study man. So, there is no universal concept which is of one type for the normal performance. It is generally defined as a rate of an average qualified worker working under the capable supervision, but not under any incentive wage plan or wage payment scheme. If worker works with the average qualification in such a way that he is not subjected to the undue fatigue, and his working is not influenced either by the supervisor or because of any incentive scheme, then that average speed of working of an average qualified worker is considered as a normal performance. The rate of working is such that exertion of the reasonable effort can be maintained day after day without undue fatigue, physical or of mental type. So, the normal performance is the average rate of working by average qualified worker who can continue to carry out the job without undue physical or mental fatigue day after day, and his working rate is also not influenced by the supervisor or any incentive scheme. So, that rate of performance is considered as the normal performance. The level of normal performance differs considerably from one organization to the another. What a company calls 100% performance, a company B may call it 80% and company C may call the same as 125%. So, there is no standard rate at which workers should work, and then only it can be called as a 100% performance or higher or lower rate of performance, and that is why it needs that the rate of carrying out a job by a worker is rated by the time study man, so that he can compare his own concept of the standard performance and the rate at which the worker is actually working. The 100% rating represents the standard performance, and this rate of working can be multiplied by with any rating factor according to the assessment of the work study man. If the work study man rates the 110% performance of a worker, means his performance is 10% greater than the normal or standard performance. If an average qualified worker is performing work with 50% more 15% more efficiency, then a standard rating becomes for that worker as 115%. So, using this rating, that the basic time value is obtained for carrying out a particular element. The observed time represents the time which is actually being timed by the time study man during the study, while rating factor indicates the rating which has been assigned by the time study man to the worker as far as rate of his working is concerned. So, theoretically the observed time and the product of the rating factor becomes a constant. This we can see with example here, which has been shown that if the observed time is 0.2 minute and his rating is 100%, then product of the two will result in 0.2, and this 0.2 will be constant. If there is increase in the time required for carrying out the job, then the rating will decrease. and if there is decrease in the observed time value, then accordingly rating will increase. Here we can see if the observed time is 0.16, then he will be rated as 125 or 125%, and again the product of the two will be equal to 0.2. In the same way, if the observed time or the time being taken by the worker is 0.25 minutes, then he will be taking longer time and he will be rated low, say 80%, and the product of the two again will be the same. So, for calculating the basic time, here we use the observed time into the rating being assigned by the time studyman to the worker and the standard rating. The standard rating is always 100% and the rating of the worker can vary depending upon his pace of working. So, here now we will see another way by which we arrive to the standard time and how the performance of the worker or the rating which is being assigned to the worker can affect the total time required for carrying out the job. If we see here, the performance of the worker above the standard can be shown using this block diagram schematically. Here it shows that if this is the basic time required for carrying out the job, which is corresponding to the standard time, and if actually worker takes less time, that is this observed time is less than the basic time, then the worker's performance will be greater, and that the extent of the extent by which worker performance is greater than the standard performance is indicated by this dark zone, which can be calculated, means this extra time means the time by which the time which is less than the basic time can be calculated from the observed time into R minus 100 divided by 100. So, here this block diagram shows that observed time being taken by the worker is less than the basic time, and therefore, the performance of the worker is rated higher than the standard performance. If the worker performance is less than the standard performance, then he will be taking longer time than the basic time, and if here this is the basic time and observed time is shown by this block, then this is the extra time being taken by the worker in carrying out the same job, means his performance is below the set standard, and the time value which is being taken extra by the worker for carrying out the job can be calculated using this equation. And here this diagram shows the different constituents of the standard time, which indicates that there is a basic time, there is work content and the standard time, in addition to the observed time, rating factor and the allowances related with. So, here this region from here to here indicates the basic time, and from here to here it indicates the work content. So, if the observed time and the rating factors are used, it will give the basic time, and if some extra time is required due to inefficient product design and inefficient manufacturing method, he will take further extra time, that that is the time in which some other work, some additional work is required to be done on the job, and if this work content is added with the allowances, it will give us the standard time. Now, after carrying out the work measurement, we will be able to see what are the what is the presence of ineffective time in existing method, and presence of any ineffective time and its extent in of the its extent in the existing method will provide the venues for developing the new method and for improving the existing method. Improvement of existing method and development of the new method is carried out effectively after work measurement which will help to identify the presence of the ineffective time, and also after the critical analysis of the existing method. Critical analysis, as I have said, that will reveal that what are the activities required, what are the redundant activities, where is the scope of elimination of some of the activities, and what are the activities which can be combined and clubbed together in order to reduce the total time required to carry out the job. And that critical analysis is carried out, as I have said, by challenging each activity in terms of the purpose and the place where it is carried out, sequence in which it is carried out, and the person who will carry it out, and the tools and techniques which are being used to carry out the same. So, after identifying the presence of ineffective time and carrying out the critical analysis of the existing method, from the inputs of these two areas are used, inputs of these two areas are used to develop the new method. Application of the critical analysis highlights the essential parts of the job and also gives the alternative ways to develop the new method. So, for developing new method, we should consider some of these factors like where and how to use the manpower which is available in the process, what better work procedures can be adopted to reduce the operator's fatigue and the time required for carrying out a given job, and what better equipment can be used so that higher productivity can be achieved, better quality product can be obtained, what better layout of the workstation, shop or factory is to be used so that unnecessary extra movements and movement of man and material can be reduced in order to reduce ineffective time and added work content. Efforts can also be made to see what kind of changes in the sequence and the timing of a particular activity or the different activities can be done, or what changes can be done in carrying out the different activities for the improvement point of view. When making the efforts for developing new method and improving the existing method, we have to consider whether a particular element or the activity is to be carried out by the machine or by the person manually. So, decision regarding the use of the manual effort or the machine is based on the capabilities of the human being and the kind of activities which are required to be performed either by the machine or the man. The decision whether a particular element of the work like operation, transport or inspection is to be carried out manually or with the help of machine should be based on the good idea about that what a man can do and what a machine can do, what is possible to be done by man and what will be better can be done by the machines. For example, large amount of the force if required for say machining operation, then workers cannot apply that consistently for long time. Exerting the force precisely, smoothly at fixed rate if required for metal forming operation, then that cannot be done manually. Then high speed computational work if is to be carried out, then that also cannot be done manually. So, it is better to prefer the machines over the manual work if the nature of job is such that it cannot be done effectively and easily by the operator manually. So, the decision regarding the use of the operator or of the machine for carrying out a particular job will depend upon up to what extent time study man is aware of and work study man is aware of the capabilities of the man and the machines to perform the repetitive tasks without suffering from the side effects like boredom and the fatigue, movement at high speed for hours together, carrying out the several tasks simultaneously, respond fast to the frequent changing control signals and perform satisfactorily in extreme conditions of cold, heat, noise and dampness. These are the situations where it will be better to use machines as compared to the manual work of the operator, and there are some of the situations where machine should not be preferred over the manual work. For example, if the activity is such that creative thinking is required, or things are to be seen and sensed first before taking any decision and taking the action. If the things are very generalized in nature, and if it is required to deal with the unexpected events during the work, then under those conditions it is not good to use the machines, but the manual the activities should be carried out manually by the operator. So, in contrast, machines prove inferior generally when activities are required to that thinking creatively, learn, generalize and to cope with the unexpected events. After development of the new method, should be developed about the procedure, workplace layout, materials and equipment to be used, and the information about the same should be communicated to for the approval of the management. Once if the things are approved, then the same should be communicated to the concerned persons like operators, supervisors, instructors, who will give the suitable instructions further to the operators and other concerned people, and the information should also be given to those who are responsible for setting up of the machinery and workplace layouts. And after communicating the things required for implementing the new and developed method, the things are installed in place. Once the proposal has been approved by the management, next step is to put the things into practice, and for putting the things into practice it is necessary to gain the acceptance of the worker, because workers may come against the new method that it is not good from the standard time point of view, or from the wage incentive point of view. So, there they should be taken into the confidence, and the suitable production plans should be prepared, so that the job can be made available for carrying out as and when the operators are free. And the retraining of the worker may also be required according to the kind of change which has taken place in the new method. And after gaining the acceptance of workers and proper production planning and giving the training, the new method should be implemented, and after implementation it should be checked regularly to see that it is being followed continuously, and the maintenance of the new method is ensured to see that workers do not slip back into the old method, and also they do not introduce any such thing which is not a part of the standard practice. So, now I shall conclude this presentation, in which have completed the things related to the time study. First, you have seen the different types of the elements, how to find out the number of observations required for each element, and how to find out the standard time, and thereafter the things to be taken care of for development of the new method, and then implementation of the new method and the required follow ups. Thank you for your kind attention, please.